Hi guys. So I got a little demonstration here I want to show this motor here. So I've got it running on 24 volts. There's, like if you've seen in my past videos, this motor has two inputs like any of my other ones. Each battery bank is separate. Each side of the motor has its own driver, and then the outputs are parallel together, and they come into this cap dump circuit right here, and then it pulses into that 12 volt battery. I can use whatever voltage I want right now. I'm just using this 12 volt. You can see here about every, I don't know, 10 seconds or so it dumps about 5 amps. There's the gauge. There's the battery voltage up there. That meter right there. The motor is also under load. There's a fan behind it on the shaft. I'll pick the phone up here right away and I'll show you guys what I got going on. None of these wires are being used. They're with these other dump loads. And also the same color coded wires in the back there, they're not hooked up. I'm just bypassing the outputs that are normally in here. But I want to do a quick demo here just to show how these motors are made and how the coils and the magnets on the rotor work together. So I'm going to pick up the phone here now and show you some stuff on the scope here. So I have the scope is hooked up right here. It's right there. So what you're looking at here on the scope, I'll just pause this. So this is the input right down here. You can see it. That's the back spike, comes out of it on that side. Anything on this side of the line, center line right here, goes through the diode and will make its way into this cap dump here, into these caps. Two banks of caps are parallel together, and they're parallel also with this one. And from there, it'll make its way into the battery with these pulses. You see there, 5 amps or so. There's the battery voltage. This bank is really, it's at its limit, and the resistors now are holding the motor back. But what you're seeing right here, you can see on some of these, the flat top. Not on all of them, but on some of these ones you're starting to see a flat top. That flat top means that it's hitting the voltage of the cap banks when the motor is off, because the RPMs are high enough that when the motor is off, when this opposite side of the magnet goes by the coil, it generates a current that goes into the output of the motor here. So let me just show you. I'll turn this back on, and then I'm going to take part of the load off. You can see it has a fan back there too, so it is loaded down. But I'm going to take this off, and you're going to see it speed up a lot, and the current on the motor will drop a bit because it's using less energy. See, it's speeding up now. Still dumping, because now you're getting, you can see here on the scope what it looks like now as it has sped up. You see all these peaks have stopped. They're all flat now. They're matching the battery voltage, or the cap voltage, I mean. 16.8 volts. You can see how they've all flattened out. That means when the motor is off on this side, this sine wave turns into a square wave because it's hitting the voltage. And so I should actually hook up the opposite side of the motor too with this other, because like when this side of the motor's off and it's generating power here just by going fast enough, this side of the motor is on. The other drive circuit is on, and it's doing the same thing. It'll flatten out and charge for free because the RPMs are high enough. That's why I've designed these motors the way they are. They generate when they're off, when the RPMs are high enough. And the torque is crazy on them, and the outputs are really high. You can't do that with an all north facing motor. And by using those type of coils, it generates on, it uses a whole magnetic field. It's a U shape. So one side of the coil is on the north side of the magnet, and the other coil, and they act as one because they're in series, is on the south side of the magnet. So it pushes and pulls on the rotor all at the same time. Always. You can see how it works and why I designed it like I did. See, those high voltage coils are all parallel together. They put out a crazy amount of high voltage. This cap bank is good for 120 volts. And it's pretty close to that right now. But just wanted to show that. You can see now it's not charging as much because it's under load rate. It still has some, not as much though. If I had a higher voltage cap bank here, the RPMs would be high enough where it still charges this, and you'd still get that effect with the rotor from the shaft. About 150 milliamps going in on each one. I can bring it down to where it doesn't even register on the meters and it still works pretty good. I just wanted to do this demonstration. Appreciate you guys watching. If you got any questions, just comment. I've been really busy lately, but maybe get back at it here again. Thanks, guys.